Okay, thank you. Maybe we can write to mute areas. Yes, unmute. Hi, Hong-Quan. Hi, Professor Hong-Quan. Yeah,
Hello.
nice joining. Thank you so much.
Hello, everyone.
I'm very happy that you could make it because we are discussing that you will be in Singapore. It will be a bit tough to join us.
Yeah.
But I think everything is working from your side. Well,
Yeah, glad to join with you. Yeah, so managed to rearrange something here, so I stay in the hotel, not to go to the university.
I think you must be attending any conference or seminar.
No, yeah, we have a collaborative program with the Singapore Management University here. Yeah.
Okay.
Yeah, so it was a big delegation, so I just excused to stay a bit today at home in the hotel.
Thank
Yeah.
you.
Yeah, thank you. Yeah,
We
hello.
are, in fact, we'll be starting at 2 o'clock. Maybe we'll be waiting for a couple of minutes. I think we can start the meeting. What do you think?
Yeah, we can start
we
the
can
meeting.
start the meeting and see that who will be joining.
Yeah.
The audience. And then I think Melita is in a meeting, but she will be joining us soon, and also Ashok Sharma. Or two speakers. Hopefully they'll be joining soon. I in fact sent the link to the Ashok Sharma, the speaker link. You click started?
Yes.
Okay. Have you started recording also? Okay, thank you.
So we have 4 minutes from 2 p.m. We can probably
yes, only 5 people. Let's people join.
Yeah.
We can wait for a couple of minutes and we'll be starting at 2 o'clock. Hi, Melita. Hi, Melita. Thanks for joining within your busy schedule. We'll be starting at 2 o'clock. We'll be waiting for a couple of minutes to join the audience.
That's all good. I just want to make sure that everything is working.
Yes, I think you can test your presentation whether it is working. You can share.
Okay.
We can see whether it is working.
Okay, let's do that. I'm just going to close most of the things that I've got open so I don't accidentally share something else.
That happens to me also.
I don't want to get embarrassed, eh? Okay, so this should now work. Share window, this one. And if I put...
Yes, it is working, yes.
Yeah, and if I'll just put it in a presenter mode, is this fine?
Yes,
Yeah.
yes.
Okay, perfect.
Yeah, perfect.
All right.
You can see. Yeah, thank you,
Okay.
Melita.
Okay, excellent. So I did stop sharing. No, you did stop me. No.
I think
Did
it.
Yes, you have stopped
We
sharing.
cannot see now. We cannot see now. So
Okay,
automatically it is
excellent.
stopped, yeah.
Yeah. Okay, all good. So just to confirm the structure, it's like a few minutes presentation and then followed up with the discussion.
Yes.
And the questions you posted are the ones that we will be following, or it's a little bit more organic?
Yes. Yeah, we'll have 3 questions I shared with you.
Yeah, okay.
Just to moderate the discussions on the topic.
Yeah, okay.
I think we can start now because we have very limited time. We have to finish everything. Let me share my slides. You can see my slides.
No, we can't
Not
see
yet.
anything, Reba.
You cannot see, okay. Can you see now? You can see now. Can you see with the screen?
On my end, it's black.
What I can see, the recording is notification for the recording. That's
I
all.
think whether anybody has stopped sharing. I think
We can see
it
your
now, Reba.
presentation now. We can see your presentation.
you can see my presentation, yeah?
Yep.
Let me in the presentation mode. Yes. Yeah. Thank you so much, and good afternoon to everyone. And thanks for joining the Water Research System webinar on valuing water in the context of circular economy. I am Reba Paul. I am a casual academic at the Faculty of Engineering and Information Technology and an adjunct fellow at Institute for Sustainable Futures, University of Technology. I am a co-lead water research stream of CERN APAC, and I am also a co-leader of its SDR and early career academics. A little bit I would talk about my research, that my research encompasses energy sensitive urban water design, water energy carbon nexus, and looking into the alternative water, particularly recycled water for potable and non-potable purposes, integrated water management system thinking, and looking into the centralized versus decentralized distributed systems, and interdisciplinary research and circular economy. I think that Ashok Sharma will be in fact talking about the decentralized systems. We have in fact another co-leader, Harpreet, but he is in fact very busy and traveling to Canberra, but he will be joining us. So before we present our webinar, our meeting, let me acknowledge, let me talk about the outline of the webinar. We have 1 hour, so we will be using a couple of minutes to acknowledge the country and introduce the CERN APAC and the water research system and the purpose of this webinar. And then we will have we'll listen to the speakers and their presentations, and then we'll have panel discussions for 15 minutes. That is a very limited time. And then we'll have question and answer sessions, and then we'll wrap up the webinar. So before we start the meeting, let me acknowledge the country. I acknowledge the Gadigal people of the Eora nation from whose ancestral lands I am. I pay my respect to the elders, past, present, and emerging, as the traditional custodians of knowledge for this land. I would also like to pay my respect to the ancestors and elders of the lands you come from. And in fact, right now that there is World Water Week is happening, I was attending online yesterday. I was very emotional to learn some statements from Aboriginal speakers, how we value water. She was telling that we have lost our rivers, we cannot drink water, we cannot swim in the water. So we'll be looking into all these issues. So CERN APAC, particularly to who are new here, that CERN APAC is a network of interdisciplinary researchers in Australia, in other Asia Pacific countries. It aims to foster cutting-edge research in the circular economy and facilitate partnership building and collaboration among research, industry, business, and government organizations to translate research into practical actions to meet circular targets. It is currently operated by 3 universities, RMIT Monash and Swinburne University and CSR Australia. It was formed in 2022, very recent network, and it is just is growing. And it has 12 research systems with currently more than 500 members. The current chair is Professor Usha Ariga from RMIT University. And the first chair was Professor Glenn Croy from Monash University. Hopefully they will be joining this webinar. Thank you to them. Water research system is one of these 12 research systems of CERN APAC. The objectives of water research systems are very aligned with the objective of CERN APAC. It has more than 40 members who are from various academic and research organizations. Water research system participated in the first inaugural sessions that was held in Melbourne in 2023. That was a very vibrant conference. I also attended along with our members, and we have presentation there on water issues. And this year, in fact, we have organized this webinar to take water further in accelerating the circular economy. The purpose of this webinar is to understand how water is valued in supporting the circular economy and identify some key challenges, opportunities, and necessary actions that can further our research and provide some policy directions. So we have 4 speakers here. That's let me stop the sharing. Okay, we have 4 fascinating speakers. That is Lesliey Gold from Beca, Australia, Melita Jazbec from UTS, University of Technology, Professor Ashok Sharma from Victoria University, Melbourne, and Professor Hong-Quan Nguyen from Vietnam National University. So let me start with Lesliey Gold. Let me introduce her. Lesliey Gold, in fact, she has a very interesting background. She is from marine science, and she is the circular economy advisor at Beca, Australia. And she has a strong focus on sustainable infrastructures, solving the critical problems using transformative thinking and fostering collaboration. She applies circular economy principles to deliver the impactful outcomes across water and wastewater sectors. And using the Beca circular economy design framework. So she will be presenting this at this webinar. So Lesliey, the floor is yours. Thank you for joining.
Thanks, Reba. Thank you. Hey, everyone. It's really great to be here and have a chance to contribute to this conference. So thanks to all the organisers for reaching out. As Reba said, my name is Lesliey and I am a circular design advisor at Beca. We're predominantly an engineering design consultancy, but also do advisory services as well. So I've spent the last 5 years or so working in the circular economy space, and I've found my passion in driving sustainable change in the water sector. So during my time at Beca, I've been facilitating a bunch of workshops on our design projects using the circular design framework. And it's sort of like a practical tool that can be applied at any stage of a project life cycle. So whether that's from planning all the way through to detailed design and construction. Over the last sort of year or so, I have been bringing my expertise into the water sector and collaborating quite closely with our New South Wales water team, Beca Hunter H2O. So by applying the circular design framework, we've helped a lot of our clients, so the large water utilities right down to small regional councils, deliver enhanced outcomes to sustainability and circularity, whether that's through implementing nature-based solutions for stormwater and wastewater assets, or reducing waste and embodied carbon emissions from water treatment plants, right through to building resilience against future regulatory changes, or supporting local economies by engaging local contractors. That's just to name a few. I'll take you through the principles of the circular design framework so that you get a bit more of an understanding. The first principle is integrating Indigenous perspectives, where I would lead some questions like, how can we integrate Indigenous perspectives into this project? Can we meaningfully engage with the traditional owners at this stage in the project? Should it have been done earlier? Could the Indigenous knowledge that the Indigenous communities hold be valuable to know for our projects? So things like the paleoclimate data, some things, the floods that have been passed down through generations as well. Our Indigenous people have walked the country for many thousands of years, so they've cared for country and lived in harmony with it. And we have so much to learn from our Indigenous peoples, and helping the water utilities understand that as well, and some of the opportunities behind that too. The second principle is designing out waste and pollution, so a key circular economy principle. This is about asking ourselves, what waste streams do we have on a project? Can we design them out? For example, in a wastewater treatment plant, how can we reduce the amount of biosolids that are produced? What locally available materials are there? Because it's no good if we're specifying low carbon concrete if we need to truck it in from 500 kilometres away. Another good one I like to ask and challenge is, do we even need a new asset, or can we make do with upgrading another asset instead? The next principle we move on to is cycling materials and assets at their highest value. I like to try and steer people away from recycled materials in this one, so it's usually one of the last questions I ask. Some of the first questions I ask are usually, can we extend the life of the asset? Can we do more regular maintenance to gain an extra 25 years from the asset? We know our water assets are built to last at least, 100-year life cycles. So how can we help maintain that asset so that we actually do get the 100 years out of it and longer as well? And then how can we design our assets for disassembly? So thinking of our assets as a material bank where we can harvest materials at the end of life. And a critical point I think to make here as well, that if we are choosing recycled materials in some of the projects, that we can still use those materials at end of life. A good example that I like to give is recycled plastics in roads or pavements. And how can we recover the pavement once it's reached its end of life? And even better yet, do we know if it sheds microplastics into the environment as the road wears down or the pavement wears down? I think this principle applies really nicely to recycled water as well, and getting others to think about how we can continue the water cycle. So some good sort of points to think about if we've got any designers or asset owners on the call as well. One of my favourite topics to talk on is the regenerating nature of the circular economy principles. I feel like in Australia we are starting to mature in this space and beginning to integrate this principle into our solutions, but some of the solutions I've been seeing are quite focused on the end chain, which is the waste, and what we're going to do with it, instead of rethinking the entire chain to design out that waste in the first place. So regenerating natural systems is all about how we can regenerate our environment. And this goes sort of beyond the like for like, if we're clearing land for an asset or treating water quality for discharge. So, thinking of nature-based solutions and how it comes into this principle, we sometimes tend to lean towards, man-made wetlands or lagoons for stormwater treatment. Replanting of riparian zones as a buffer for flooding as well. The next principle is creating socio-economic benefits. So this is one that we've added in for a more holistic sort of view. And it's about making choices that benefit the local community in an equitable way. So what local contractors can we use? What have the community expressed views on that they would like to see in a project? And have we made sure that we're engaging with everyone in the community, especially those marginalised groups, so that we're creating an equitable asset for the future? And asking the question from a water perspective, does everyone in the community have access to safe, potable drinking water? And if not, how can we enhance that and make sure that we are supplying safe, potable drinking water for everyone? So those are the sort of types of questions that we sort of ask when focusing on this principle. Finally, the last principle is increasing resilience and adaptation, something that's particularly important in a changing climate. For the designers and asset owners on the call, what sort of climatic impacts are we designing for? Have we considered if those impacts are going to get worse, like flooding? And then thinking about energy sovereignty, what if the power goes out? Can we still operate our water treatment plants? Can we still provide safe, clean drinking water to our communities? And then thinking of nature-based solutions as well comes into this one, because they help build resilience to the impacts of flooding or storm surges as well. So I guess to wrap this up before I get told for running over time, sorry, Reba.
No, thank you. Yes, I was waiting. Thank you so much, Lesliey, to maintain the time. I think it is fine. And in fact, that this framework, in fact, I looked into that. It is very useful to apply in the water sector. Already you are applying. And
yes.
So water, in fact, not only as an economic good we need to see, but it has both social, cultural, and environmental aspects. And the
Absolutely.
resilience, in fact, resilience and climate adaptation is the theme of this year World Water Week. There are a lot of discussions, and he very much talked about energy. When energy goes out, it will be the case to provide water. So, in fact, there is also a very good session that I attended yesterday that is on decarbonizing water infrastructure, where the Professor Stephen Kenway and the Professor Greg Lesliey from University of New South Wales are the speakers. So thank you so much. Now I would like to invite Professor Hong-Quan. Hong-Quan, in fact, is an associate professor and the leader of the Institute for Circular Economic Development at the Vietnam National University in Ho Chi Minh City. Her specializations are environmental management, transdisciplinary research, and partnership building. And thank you, Professor Hong-Quan, to join us from Singapore when you are have some meeting there. I think I would like to listen from you that what you are doing in the water sector to achieve circular economy. Thank you.
Okay, thank you so much, Professor Reba. Hello, good morning from Singapore here. So I'd like to share my screen. Okay, can you see my screen now?
There is a question. Yes, I cannot see still. You like to show some slides, Professor?
Yeah. Yeah.
We cannot see again. Can you try again?
Okay. Okay, can you see my?
Yes, now we can see. Thank you.
Okay, great. So I try also to manage in 5 minutes. I just want to share with you some case study from Vietnam. So I will also skip some background. Actually, I have water background, but in the last 5, 6, 10 years, I've been also towards more sustainability and including circular economy. Also, just maybe also skip our university, which is Vietnam National University, and also our institute, where we are trying to work as a platform to connect different stakeholders, also working across different disciplines, and so circular economy across different scales. Okay, maybe just a quick background about water policy related in Vietnam. So you see the cross-sectoral linkage between different industries, sectors in Vietnam, from Ministry of Natural Resources Environment, who's responsible mainly for water, but of course it's linked also to other ministry, including Ministry of Industry and Trade, Ministry of Construction, for example. And actually this is really, I have to say, they're a little bit limited or quick multi-level institutional capacities, and it's rather more regulated, limited to incentive in water management policies. Just give you some highlight water-related issues in Vietnam. We are facing, for example, with urban floodings, also flash floods in in some highland areas, and limited clean water supply. Is it groundwater exploitation, especially, for example, in the Mekong Delta, where it's also cause land subsidence, and we have problem with surface water pollution due to limited water control, both pond source and diffuse source. And we have river transboundary issues, not only in Vietnam, but also international river basin, including the Mekong rivers and also the Red River basins. And we also one of the top country affected by climate change and sea level rise. Just give you some example that we are working on water-related circular economy. This is example we try to, because as you mentioned, groundwater over groundwater exploitation in the Mekong deltas, and we work with some internet is the Dutch expert to how we can reduce groundwater, but also provide water recharge to the groundwater system in the Mekong Delta. Another example is a project with Volcanic University where they are looking at how water circularity can be applied in industries and also especially at the industrial zone, industrial parks. Another project that we work on water circularity within a circularity plan for an island, Kondao Islands, where it's officially approved by the local governments, and within that the water circularity included and coverings different subjects, including developing more reservoir in the mountains, increasing rainwater harvesting and management, and constructive water use, reduce wastewaters, water savings and efficiencies, desalinations in the island, and integrated water, food and waste management. So actually the plan was approved and have been implemented over the last 2 years until 2030s. Another example where we are using looking at how regenerative agriculture can improve water management. So actually in this circular economy, you can see, which is, for example, the interaction between water management and sustainable farming system. So the two example here is the mangroves and shrimp models, where it's the symbiosis between rice and shrimp, where the food from actually from the rice can be also used for shrimp, and the shrimp can realize and also actually the water and lands ecosystem very much clean, and and also if we look at the whole value chains of this farming system, we can also include looking at not only at the farm scale, but also look at the value chain, including to the market. And here we can also, let's say, looking at how the payback from the customer, for example, the carbon credit or other green values can be payback to the farmer so that they can improve their livelihoods. So this also similar where you have see the next another pictures where the shrimps and mangroves and so can be integrated. The last example is this where we just published a chapter how circular economy in water can be put into the strategy, sustainable consumption and productions, where we also provide a number of agricultural food system and industrial manufacturing, circular economy, and also service tourism. So actually now we're also working on another review papers how circularity can improve water governance in the cities. So by that, I would like to end off my presentation. Thank you.
Thank you so much, Professor Hong-Quan. Actually, that you presented a very good presentation that is from Vietnam, what you are doing of our water circularity. And you are very much looking into the whole water cycle management in Vietnam. That is very important. And transboundary, in fact, the big issues in the Asia Pacific region. And we need also look into that, how we can act locally and think globally. Thank you so much. Now I would like to invite Melita. Melita, thank you so much for joining within your very extremely busy schedule. I think you have another meeting at 3 o'clock, you told me. So Melita, in fact, is the research director at the Institute for Sustainable Futures for Resource Futures, and she's a chemical engineer, and she develops circular economy practices and applications, and review the circular economy that is procurement, and also that look into economic for the water sector. She also developed the water strategy and action plans for Australian councils and private companies, and also advises the planning for new developments. That's very important to accelerate the circular economy in the water sector. So, Melita, floor is yours. Thank you so much.
Thank you very much, Reba. Thank you for the invitation and opportunity to speak today. So I'll talk about how can the water sector transition to circular economy, and go through about 3 projects in this couple of minutes. So I'm just trying next. Okay. So about 5 years ago, we developed this paper with the title Transitioning the Water Industry with the Circular Economy. And at the time was one of the few resources made available, which is giving a little bit of a roadmap to the water sector, how to transition to circular economy. And the paper itself presents also case studies, how the theory can be put in practice. So if we look at the water, if we can see the water as being a resource, as well as a nutrient carrier, source of energy, in addition to the service what water sector normally offers, we can start to understand the opportunities in the interaction that can be found with the other sectors as well, and the role that water can play in terms of circular economy. The 3 principles presented here, you will be all familiar with, have been predominantly developed for the our, let's say, inorganic product-based system. And when we think about water, obviously they don't translate quite directly. Here, however, is if we were to try to translate them, what does this mean for the water sector? You can see a few ideas have been put forward as well. So now, in terms of transition, if we can think, we propose this framework, how a water utility, for example, can look at the steps that they can take from, let's say, doing less harm to doing more good, and what is in their control and what is not in their control. So firstly, the solutions that can be implemented by the utilities within the sphere of their operation and control are predominantly based on the efficiency and how to lower the environmental impact that they do. If we look at a bit broader outside the water utility, then it can play a role of the restoration. So the solution that consider a broader material system view, that would include, for example, capturing the nutrients in the wastewater facilities and delivering those back into the agriculture. And if we look at the third step, when we look at the broader society boundary, in this case, water does the so-called regenerative stage. It has a positive outcome, not just for the environment, but also for the society. The role that it plays for, let's say, the humans. If you can imagine a fountain in a village or in a city where people come together, it brings another value, not just having a clean water source. So it's not just what water could do from engineering, let's say, point of view. It's also for the well-being point of view. Now, we looked for the Sydney Water is building an Upper South Creek Advanced Water Recycling Centre in Western Parkland City. And what they wanted to understand is how could they become more like a circular economy hub, looking at accepting waste from externally from the wastewater, and the types of waste that we were looking at included food waste, commercial food waste, fats, oil, and greases, and looking at the co-digestion at the wastewater treatment plant. So this was specifically for the case and for the next 10 years. And what we tried to demonstrate through this study was that not only would this assist, let's say, diversion of the waste from landfill, it would also eliminate the need to build specifically designed facilities to process organic waste, such as food waste, but also does make economic sense for the wastewater treatment plant. And it does put it in a different position where it also looks at waste management, not only on the just delivering the water. And this study calculated what were the financial benefits, including the job creation, but also the energy, the generation of energy that can be either used on the plant or provided to the community, utilizing biosolids by capturing the nutrients, and then also the reduction of greenhouse gas emissions. Also, similarly, we were trying to identify the other opportunities across Sydney area and look again with the same notion of thinking about wastewater treatment plants being a circular economy hub. And as I mentioned already, the waste diversion from landfill, but also an opportunity to bring the sectors of energy, water, and waste together to share the data and knowledge and understanding of all the opportunities. This, and to put in the context of the importance of doing this, just looking at 3 water treatment plants in Sydney and the surrounding areas, this by itself could provide the 20% of, could fill the 20% of the identified gap for anaerobic digestion in Sydney for 2030. And I'm happy to share all these reports and not go into the detail in the interest of time, but happy to take also the questions later and provide more details. So I'll stop here.
Yeah, thank you so much, Melita. Thank you to talk about the lesson learned from the work that you are doing with the Sydney water. When you mentioned about the Malabar, I was in fact reading one news article that Sydney water is going to spend $32 billion, but it will not stop the pumping the sewage into the sea. So maybe we'll be coming to the discussions all about that. Thank you so much. Now I'd like to invite the Professor Ashok Sharma. Professor Ashok Sharma is an associate professor at the Institute for Sustainable Sustainable and Livable Cities in Victoria University. And her specialization is that the planning and design of centralized wastewater, and stormwater managed systems, and water sensitive urban design, and fostering collaboration. So, Ashok Sharma, this floor is yours.
Thank you, Reba. I will try to share my very brief presentation, and all the three presenters presented very well. My presentation will be very basic, and I mainly work in the area of water resources and water infrastructure, but a very small component of looking what water is playing a role in circular economy. My personal thinking is that I will put this in a slide mode. Just give me a minute. Yeah. Okay, thank you. So my personal thinking is that if you're able to apply the alternative resources, they can also, whether it is a new development or existing urban developments, it can also contribute significantly to the circular economy rather than just thinking about using water in some other industrial areas. Because it is also addressing few things. One is because of the climate change and population growth, there is a significant load on freshwater resources. And also because of that, there is a lot of wastewater or stormwater being discharged into the receiving environment, which is also impacting. And also the reuse can also have some economic benefits depending upon at what scale we apply those approaches. So the decentralized and centralized systems and distributed system, which can significantly play role in this area. It can be either through the rainwater tanks or using localized wastewater for reuse and different type of systems. And then also water settlement design that is also becoming stormwater harvesting approaches, again, playing significant role. Basically, these type of system can also provide water wastewater services at different scale. And the idea is fit for purpose. I think that is the main concept. And why these are beneficial? Because basically, where we are generating wastewater, stormwater, we can use resources locally. So we don't need large reticulation system, which can be and also the wastewater stream, which is being generated at a point where we can be reused. So these are some of the benefits which can be applied in terms of using decentralized distributed system. But the scale is again a very, very big question mark, that what is scale these type of system can be very economically utilized. And there is a need for doing a lot of research in this area. We have some examples, and I will try to give you some examples how these systems are being, what benefits we are getting in terms of the water capturing. Like, for example, rainwater. Almost all these states, they promoted rainwater tanks for a long time, especially during the drought period around 2008, 9, 10. And we conducted a study which was done in Urban Water Security Research Alliance in Queensland, and we looked basically from the modeling point of view, we can find out so many numbers that, okay, we can capture so many kiloliters of rainwater every year, but how actually practically post-implementation impact assessment was never done. So we conducted a study, looked nearly 20 rainwater tanks in homes, and did the all instrumentation, and we found that we can achieve roughly around 40, on an average, 40 kiloliter of rainwater that can be utilized within the homes. When the other hand, the overall consumption was 150 kiloliters. So this is something which was a good output in terms of, yes, they are effective. and they can provide some amount of rainwater, which can replace the freshwater resources. The another study we conducted in Canberra, and the aim was how we can achieve 25 or 30% of freshwater resources and 20%, close to 20% in the reduction in the wastewater. So we did a lot of modeling and looked nearly 14,000 homes, the data, and we came up with the conclusion that if we are using rainwater tanks, we can achieve up to between 22 to 33% reduction on freshwater potable water supply. But if we combine with grey water and rainwater both and use them locally at homes, we can achieve between 34 to 41% reduction in freshwater potable supply. Based on this study, ACT government adopted the providing subsidy program and changed the policy to provide subsidy for installation of rainwater tanks. So these are some of the systems which are really can be beneficial. And similarly, the another study which we conducted was in Calcula Development, which is locally in Melbourne. Yarra Valley Water, they were developing a new area with 80,000 population, and they asked us to look all the possible options where, and then compare with the conventional approaches, with centralized approaches for that area. And as you can see that freshwater resources potable supply can be reduced up to 50%, very close to 50% if we are using local wastewater recycled, and also we can treat it and recycle. And similarly, if we do stormwater option, that is another possibility, but in that case, we have to treat the whole wastewater. And then you have to see the economics aspect of that, and that study was also conducted. But my presentation that includes, yes, these type of approaches are good, and that contribute directly or indirectly into the circular economy. The another case study which I would like to present is about the local in another area, which is a new growth area coming up in Milton, where they are again thinking for a large population and also 13,000 hectare new development, which is planned over nearly 20-30 years time. And there is a lot of.
We are running time. If you can
just
be a little
give me
faster, thank you.
10 seconds more.
Thank
and over there, I think we looked how much stormwater can be captured in that area, and we found that there is a significant amount of stormwater that can be captured based on considering the climate change impacts, and even close to 80% of the potable water supply can be managed through the collection of stormwater. Then the question will be the treatment of that stormwater to a potable standard. And there are a number of other options. It can be discharged into the nearby water reservoir, and then from there it can be treated and supplied. So this is my last take is that yes, these approaches can also contribute significantly to circular economy. That's all from me. Reba, thank you.
Thank you so much, Professor Ashok ji. And in fact, stormwater, rainwater has huge potential, no doubt, and for regeneration particularly, and also. And the scale is a very big, important issue that has been always discussed. And you know, that's about the water-related energy. That's what is my expertise here. So thank you so much. We'll be take some question at the end. So now we'll go to for panel discussions. Let me talk about the. In fact, we had planned to go one by one, but we will in fact just we'll look to the question, discuss the questions together. Let me share the questions with you. That will be better, I think. Can you see the questions?
Yes, we can.
Yes, that I would like to. So the four speakers will be working as a panelist for this panel discussions. So first question, in fact, that why water is less focused in the circular economy compared to the energy and nutrient. Melita, in fact, very much discussed that what she's doing with the Sydney water, but still I think that more focus has been to recycle energy and nutrient, and less has been less has been to how to reuse the water, particularly that it is very difficult when the water is recycled in the centralized systems. But Melita is also working the pressing level. I know that there are a lot of work is going on. And so I would like to look into your insight here for your insights on policy directions, or it is due to perceptions on valuation of pricing of water or infrastructure login. Another thing, what collaborative models can work. Melita can give very good highlight on this, as she has got a lot of experience working with Sydney Water. And last is that what actions, critical actions we can take to better value water to accelerate circular economy. So if you can speak on that, I think Melita can speak on these three questions, and then we will take others.
Okay, thanks, Reba. Yeah, I think like just to summarize all of them in a way together. So I think there is obviously, if we focus on recycled water, or if we think about if we have cleaned the water and then used it for potable use, as opposed to let it go into the nature, because in fact all the water eventually is recycled. If you think as the whole system, as a whole planet. But there is, my understanding still predominant is the acceptance in the community, or that yuck factor, that they don't want to actually drink something that they think has been before cleaned wastewater. Despite all that, Sydney Water has actually just opened recently in the last few years a center where specifically designed to educate community about the safe use of the recycled water. And I think our speaker from who is lives currently in Singapore might enlighten us about how this could be applied, or what could we learn from Singaporeans in terms of accepting that. When it comes to collaboration with the industry in between researchers, I think some of the bigger organizations definitely rely on researchers, and they are obviously, my experience is they're very safe in their promoting new ideas or installing new applications. When it comes to nutrients itself, I think we do not recover what we should, but I think the biggest waste in Australia, from my personal perspective, is how few anaerobic digesters are around the country in wastewater treatment plants, so we're not recovering energy as well. I think that was, I'll give other speakers a chance to say something too.
Okay. So can I request Professor Ashok Sharma to give your insight into the three questions?
Thank you, Reba. I think Melita has already provided some insight, which is, I think, we all will be going in a similar direction. But for the first question, if I take it, I think the economics and also the resource constraint that is pushing more towards the energy and nutrient recovery rather than looking the water. And water recycling, I think the same aspect is there is a perception issue, and then the distribution needs a lot of infrastructure. So that's why I think the priority was to look the energy, and then most of the water utilities are also thinking towards moving zero emissions target. And there is a lot of resource constraint towards nitrogen and phosphorus. I think that's why there is a lot of discussion going on picking up those resources rather than looking the water aspect. That's it.
Also hydrogen.
Yeah, hydrogen and another. And luckily we got this year funding from DFAT for conducting research in production of hydrogen from wastewater, which we are starting very soon with CSRO. And that is something we are also getting some industry support for that project. And the second question is basically the collaboration part. I think, again, Water Research Australia, I think they're trying to be helpful in that area, putting researchers and industry together, but it's still resources are I think the main constraint in that but like for example earlier the Goida Institute for Water Research and Urban Water Security Research Alliance, they also played significant role in that area. And still we need a lot of collaboration with industry. There is smaller collaboration at individual level, there is still happening, but yes, there is we have to look into much more how the government can promote and what type of policies are needed. That's something which needs to be discussed and debated a little bit more. Future opportunities, I think one is that there is a lot of push coming up for using AI in water management, and there are not only water management, but there are so many data centers coming up, and they will need a lot of water for cooling systems. So recycled water can also be uh, more substitution can be used in that area. That is one thing which I'm thinking. And there will be some more opportunity in terms of looking, using and promoting more distributed systems locally. So this is something which I would like to add over here. Thank you.
I wanted to raise one thing that's so water has a very significant role to contribute to circular economy. There are many large, if you look at Australia, that there are many large recycled water projects and also water efficiency program, very long-term water efficiency program. But are we measuring that how that has reduced the carbon emission, whether that kind of measurement is there? I think that ISF in fact developed some metrics, and I don't know that how that can look into the quantification of what are that contributing to circular economy. Maybe Melita can give some highlight, then we will go to Lesliey and Professor Hong-Quan.
So clearly, if you do capture, so for example, through anaerobic digestion, if you do capture some carbon emissions, the whole system is different when you do that, when you change from aerobic to anaerobic. So clearly there is savings just based on that. And yes, there is methodology developed and is accepted as well in the reporting, how it's measured, what is the reduction in that system. I think the emissions that are to be careful about in wastewater treatment is particularly the nitrogen that come, the N2O, and those are significant. And as you probably all know, it's about 7% of the emissions come from that worldwide. So in that sense, that has been, but I think in all areas there is still a lot to be done, and it's also the whole concept of needing to think across the different sectors. So even when we look at the project and research that is currently being done on biogas, it never considers what happens to digestate. It only focuses on biogas. So even though those both are two products of the same process, we just ignore one, or is the other way around, we focus just on the nutrients. So I think there is a huge gap, and this is up to us for researchers to collaborate together and work across different sectors and share the knowledge as well.
Thank you so much, Melita, for your insights. And now I would like to listen from Lesliey Gold. Lesliey?
Yeah, thanks, Reba. Picking up on Melinta's point there around cross-industry collaboration, I think that's a really good point, and I actually had that in my notes to talk to about the future opportunities, because we really need to foster partnerships between government, industry, and research institutions, as well as communities. We need communities along on the journey as well, because one of those barriers are to recycled water is that stigma around drinking recycled water. So we need those on board as well and start getting the education moving, like with Sydney Water. I think the collaborative platforms can really break down the silos that we've developed in Australia, because we keep wastewater, drinking water, stormwater quite separate, when we need to sort of look at those as a holistic view of the water cycle, essentially, to be able to integrate them quite well. I think another sort of challenge in our water space as well is that most of the assets that we're dealing with and upgrading were built on a linear economy model. So it's been quite challenging to try and integrate circular perspectives into those linear built assets as well. And again, the regulatory hurdles across some of them as well. I was listening to a presentation last week where the main challenge was a regulatory hurdle for a small-scale water treatment plant. So I think, yeah, working together, cross-collaboration, and bringing our communities on the journey as well that we're all facing, because we need them on board for the future as well. Thanks,
Thank you so
Reba.
much, Leslie, that in fact, we cannot come out from this linear centralized system. Thank you for mentioning that. Another thing is that regulatory hurdles, that is very important, that we have not consistent regulatory framework for fit for purpose water and other issues. Thank you so much. So I would like to listen from Professor Hong-Quan now. Hong-Quan, this floor is yours.
Yeah, thank you. Yeah, I think college already share a lot, so I just maybe some minor talks about this. So maybe to the first question, what I'm concerning is why water is not really yet been focused in circular economy. I think one of the key reason is the values of water is not really well institutionalized. So we can, especially those values in environments or social values. So we don't have really people to pay really the full price of those values. And for example, this also come to the case here in Singapore. The water is too expensive or too limited, and the recycled water is go up to 40%, and hopefully can increase in 55% of the total water supply in Singapore. So just example where people really value the water and they use. And the second, I think the success of collaboration between governments and others, I think is very clear example in Vietnam, especially where in the coastal or in some remote areas where people are highly relying on rainwater. So the case, I think, from Professor Ashok, I think is quite often we see in Vietnam. Where local people work with others to including philosophy actors to supply the waters for really rainwater. And I think the future of waters, I'm still very much interested. I think how the waters are integrated with other sectors. I think we have been discussing a lot already on that with energy, foods, and other nexus. Uh, but I think also Professor also mentioned about advance of AIoT or digital technology. I think they can improve the integration, including creating more business models on water circularity. So I think it could be have in the near future. Thank you.
Thank you, Professor Hong-Quan. Actually, yes, we need a business model for circular economy, particularly in the water sector. Thank you so much. Now we can look into any questions from the floor. Is there any question? I don't see any questions, but we would like to open the camera or the mic. That's anyone like to speak to the panelist to ask any questions.
I see there are questions on water footprint.
Water footprints, yes, I have some questions I see here. Yes. Yes, Harpreet has mentioned some question. This is a question for all speakers. Has anyone worked with water footprints, studies to establish a baseline water used per unit and then track how we are improving the circular economy, or whether there is any formal system in place to compare water footprint for the same product across countries or economies to assist progression to better water use efficiency. Anyone would like to answer? This is a very critical, but a very in-depth questions.
So, Reba, I can briefly talk about it. I think when we're talking about water footprint, it depends upon where we are using that water, and if we're whether using for some industry and looking for production from that industry, and then looking per item that has been produced, or in terms of weight. So there are so many aspects of looking footprint. And if you're looking from the city point of view, how much water is being used, what is the population where it is being used. So many factors and dimensions to look into this aspect. And it is a very complicated area. So it's very difficult to answer in one sentence that how we can estimate. But there are some methodologies which are available, and they can be applied depending upon the scale and the location, and also the resources available and the production, which is where we want to apply it.
Thank you, Professor Ashokji. I wanted to add that, in fact, the water mass balance can help in this respect. You know, that was, in fact, my work in my master's and the PhD also. I utilized that water mass balance analysis. In Australia, in fact, some study has been done regarding the water footprints by Professor Stephen Kenway, and I also did for Bengaluru, based on their work in Australia. So I think we need a lot of work. When we talk about circular economy, the assessing footprint can help monitoring the circular progress. Thank you so much. Another question is Professor Usha. Thank you so much to raise this question. Thank you to all speakers. My question is that what changes do we need to consider urban planning across Australia based on the experience of all speakers? If you can give some highlight to Professor Usha, our chair for circular, for CERN APAC.
Sorry,
What
can you
changes
say
do
again?
we need to consider in urban planning across Australia?
I think a lot of already being talked about water sensitive urban design, and looking the water is one component of that, and that should be incorporated in the urban planning. So that is a very brief answer from my side, but there can be a number of other approaches which can be considered. And then the looking how we can reduce the urban heat island impact, which is again a very critical aspect in the core part of the cities where the temperature rises, and all those aspects of how we can minimize that impact and the heat island impact. So again, the water can play a significant role in that one. And there are different approaches for that. So I will let others speak more about it.
Melita, would you like to add something regarding the questions? What changes do we need to consider in urban planning across Australia to accelerate circular economy in water sector?
I guess, well, where do we start? There is a lot of planning. Like at the moment, of course, there is a need to change around the third principle in terms of enabling the more of that regenerative opportunities. It is also about how the water is being pumped around at the moment. And as our speakers have already highlighted this before, is that the whole system has been designed very linearly. So you have your wastewater treatment facility on one location, while you have the cleaning of the potable water and reservoirs really far away. from each other. So you couldn't even integrate, even if you wanted, without an excessive amount of pumping around. And also looking at more place-based solutions, kind of more decentralized opportunities as well. There's been so little work done, or also the way that the water, who owns, who are, let's say in Sydney, we have Sydney Water, very minimal amount of smaller water companies. So the opportunities are very limited as well from that perspective. So there's, yeah, so it's quite big systemic change needed in order to make the water more circular. But yes, so it's like yeah, as we're running like out of time, I think it's about probably another full session just on that.
Yes,
required.
yes. Thank you so much, Melita. Actually, that's we need a lot of energy for water treatment and wastewater treatment and disposal. And our system is very linear. To come out from this system, actually, we need to transition to the decentralized, particular distributed system, which are the mid-scale system. That was my research in PhD, actually, that is looking into the energy sensitive urban design, that I did my PhD at UTS, from the same university that Melita is. So we need to look into that, and we also need to look into that water sensitive urban design and how we can decarbonize the water infrastructure, looking into the resilience of water systems. And I thank you so much that we in fact discussed a lot of challenges and opportunities and the collaboration across water sector that can in fact help accelerate circular economy. Thank you, the excellent speakers and panelists for joining this session. I am really grateful that you could make it. So we would like to see again. Thank you so much, and thank you the organizers, that is CERN APAC, that who organized the webinar. Thank you so much.
Thanks,
So
Reba.
Thank
Thanks,
you.
everyone.
Thank you.
Thank
Thank
you.
you.
We'll end the
Bye.
session. Thank you. Bye-bye.
Bye.
Bye. Bye.